All right, finally, on our last video, part D of number 8, we went ahead, wrote our equation, all right, making sure we had our acid, our base, always makes a water and a salt, and then I went from the problem and realized we had 50 milliliters of carbonic acid, at 4.5 molarity, so I put those underneath that. This is just a continuation of that because I had to convert milliliters to liters. And over here, it's asking for how many grams of KTCO3 are going to be produced. I cannot go from molarity to grams. I need to convert it to moles, which is what this sort of sideways crooked writing is doing. And that's what we did in our last video. We found out that there's 0.23 moles of carbonic acid. So that brings me down to the bottom here. I'm going to try to now convert moles of carbonic acid to moles of potassium carbonate, the KTCO3, to grams of potassium carbonate, because see, it's asking for in grams. So these values, remember when we go from moles to moles, always need to come from our equation. So 1 mole of H2CO3, so I'm going to put a 1 there. 1 mole, because, you know, we look at what's in front, 1 mole of K2CO3, so 1 there, so that basically does nothing to change our math. And then right here, so we're going to cancel out. We know our moles cancel out. So when we're going from moles of KTCO3 to grams of KTCO3, we need to use molar mass, which is what comes off of our periodic table. We go through and add those together, 2 Ks, 1 C, 3 oxygens, we should come up with 138.2 grams. That's how much 1 mole of potassium carbonate weighs. You're going to go through and do your math. 0.23 times 1 divided by 1, which does nothing, times 138.2. And when you go through and do that, we should come up with 32 grams, move that over, of our K2CO3, which is our final answer. We only can have 2 sig figs because way back over here we only had 2 sig figs. So this is where we get our 2 sig figs in our final answer. All right, that is the end for chapter 8, or not chapter 8, but problem number 8. Thanks, guys.